Hello everyone, welcome to module 5. So in our last modules, we have covered different aspects of UX design, and from this module, we will start learning practices of UI. So let's start with defining requirements. Design begins only after the requirements have been established. At this stage, the focus shifts from understanding what the system must do to how it will look, feel, and behave. There are two major forms of design, first, the conceptual design, and then the physical design. So, conceptual design is about defining the product structure, behavior at a high level, and creating a conceptual model that represents how user will actually interact with the system. And physical design, on the other hand, deals with concrete details such as the interface layout, color schemes, how the icons will look like, navigation structures from button to button or from page to page that users will actually see and use. So, importantly, design is not a one time step but an interactive process. It evolves through repeated cycles of design, evaluation, and redesign. So, each cycle allows designers to refine their ideas based on user feedback, usability testing, and observed interactions. To make this possible, designers must build prototypes, interactive versions of their ideas that user can see and interact with. So these prototypes can range from simple paper sketches to detailed um, working models that closely resemble the final actual product. So there are two main design scenarios. In some cases, designers start from scratch, developing a completely new product. In other cases, they modify existing products, adding or improving features. While it might seem unnecessary to test small changes, skipping prototyping and evaluation can lead to usability issues later. So, even when modifications are minor, testing ensures that the changes genuinely improve the user experience rather than creating new problem. So prototyping is one of the most powerful tools in the design process because it helps transform ideas into tangible experiences. It's often said that users can't tell you what they want, but once they see something, they quickly know what they don't want. So, this means that simply asking users for requirement is not enough. They need to interact with the existing design to provide meaningful feedback on it. After gathering information about users, work practices, goals, and preferences, designers move into prototyping where they build early testable versions of the system. These prototypes allow both designers and users to explore what works and what doesn't. So, as users engage with each prototype, their feedback helps reveal design flaws, missing features, and usability challenges that might not have been obvious earlier. This process is highly iterative. Designers create and then test, refine, and rebuild multiple versions of the same system. Each cycle improves the product's usability, performance, and alignment with users' expectations. The principle is simple. The more you iterate, the closer you get to a product that truly fits the user's need. So, in essence, prototyping and construction turn abstract ideas into real testable forms and serve as the foundation of creating interactive systems that are both functional and user friendly. So, what is a prototype? A prototype is essentially a simplified version of a product that represents its design concept. It allows designers, users, and stakeholders to visualize how the final product will look and behave. Importantly, a prototype is not a finished product, it's a tool for exploration and communication. Prototypes serve several purposes. They let users interact with early design ideas, test workflows, and provide feedback before full development cycle begins. Through this interaction, both designers and users can uncover usability issues and refine their understanding of how the system will function in real world use. The form of prototype can vary widely depending on the design stage and the purpose. In early phases, designers might use paper sketches or storyboards to visualize screens and interactions, and later on, they might build digital mock-ups, video simulations, or even 3D models to represent physical devices. The key idea is that the prototype should provide enough realism for users to imagine actual use without needing to build a full functioning system. So, to summarize, prototyping transforms abstract ideas into something tangible, giving stakeholders the chance to experience the concept before investing heavily in development. Prototypes can be as simple or as detailed as needed. The most important thing is that they allow people to visualize and experience how the product will function in real life. So, here are a few examples. Um, For example, the Palm Pilot, one of the earliest handheld digital organizers, its creator Jeff Hawkins craved a small piece of wood to the exact size and shape he imagined for the device. He carried it around and pretended to use it, entering imaginary information to simulate what owning such a product would feel like. This simple wooden block helped refine his vision and the device's interaction model long before any kind of electronics were even built. So, here are a few more examples. So, these examples highlight that a prototype doesn't have to be functional or high tech. It simply needs to help people experience, evaluate, and reflect on the idea, whether made of wood, paper, or software. Prototypes make it possible to test assumptions and refine concepts early, saving time, cost, and effort later in the design process. So, prototyping is more than just making a mock up, it's about turning imagination into something we can see, touch, and discuss. It brings everyone, designers, stakeholders, and users onto the same page. When people can actually see or interact with a version of the product, their feedback becomes much clearer and more grounded. Now, one of the key benefits of prototyping is what Donald Sean called reflection in action. This means that as designers build, they also think, analyzing what feels right, what doesn't, and adjusting their approach in real life. It's not just doing, it's thinking through doing. This reflective process helps uncover better ideas that pure planning might never reveal. Now, what exactly does a prototype do? It answers question and it supports decision. Designers use it to check if an idea is technically feasible, to clarify unclear requirements, and to observe how real users might interact with the system. So, in this way, prototyping connects imagination with practicality. It tests possibilities before full commitment. For instance, imagine a paper based prototype for a communication device created for an autistic child. The button on the paper didn't work, but that wasn't the point. What mattered was that users could test the layout, labels, and usability. Even a non functional prototype like this can reveal whether the design supports the intended interaction. So, when we ask why prototype, the answer is simple because it's how ideas become real, how designers learn by doing, and how we make sure our designs truly serve their users. Now, let's take a moment to look at the figure which shows the communication mate. A simple yet powerful example of how prototyping can make ideas tangible. This was a paper based prototype. Yes, just paper, but it represents how a real communication aid would function for autistic children who face challenges expressing everyday needs. Even though it didn't work electronically, it simulated the experience of using one. So you will notice the five main keys labeled biscuit, cake, dinner, drink, and toilet. So each one is a touch sensitive panel that in the real device would play a recorded message when pressed. So that the idea is very simple. When a child taps biscuit, the device would say the word out loud. This bridges communication gaps without overwhelming the child. So each key also includes a symbol or photo, allowing the child to rely on visual memory instead of just reading it. This visual consistency support quick recognition and reduce confusion. So it's a great example of user-centered design. Now, if you look at the physical design, the prototype emphasized safety and usability. The case is durable, shock resistant, lightweight. There's a battery indicator to show when charging is needed, and a ring attachment to so caregivers can clip it to a belt. So this design demonstrates that a prototype doesn't have to be digital to be powerful. Even a paper model like this can communicate the concept effectively, helping designers and users visualize how the product might fit into real life. It's a reminder that good design starts with empathy and sometimes with just paper and imagination. Now, prototyping can be explained in three categories, mainly low fidelity and high fidelity, but there is a mid fidelity prototyping in between. So let's start with low fidelity prototype. It's a vital step in early design where creativity and flexibility matter more than polish. Unlike the high tech refined version, we often imagine how low fidelity prototypes are intentionally rough and simple. They can be made of paper, cardboard, or even a piece of wood. Like the Palm Pilot prototype, which was literally carved out of a wood block to simulate size and feel. The goal here isn't realism, but imagination. Low fidelity prototypes are incredibly valuable because they are fast, cheap, and easy to change. When you are still exploring ideas, you don't want the fear of breaking something to stop creativity. So, these prototypes invite everyone, designers, users, stakeholders, to think freely, give feedback, and reshape designs on the go. So, low fidelity prototypes are not about perfection, they are about exploration. They help us visualize ideas, refine concepts, and build confidence before investing in more complex stages of the decision making. Um, Now, let's take a look at the example of storyboarding. It's a visual technique that helps us map how users interact with the system step by step. Storyboarding, as you can see on the slide here, uses a series of sketches to represent different stages in a user's journey. Each frame captures a specific interaction, just like scenes in a movie. So these approach makes abstract ideas tangible and help team visualize how a product will actually be used. Here, the storyboard shows a person using a system for digit. digitizing images. It begins with the user scanning diagram and pictures and then moves to the artist's ending the images, followed by an automating program generating buttons, and finally data being read from a larger computer. Even without detailed drawing, the sequence clearly communicates the user flow and the system function. What's powerful about storyboarding is how it helps communicate user experience and design logic in a simple visual way. It doesn't need to be perfect art, even quick sketches are enough to spark conversation. Stakeholders, designers, and even users can role play through its steps, acting out the process to uncover potential issues or opportunities for improvement. So, storyboarding bridges the gap between concept and experience. It allows everyone involved to see how interactions unfold, understanding user behavior better, and refine design ideas early before investing time and effort into complex prototypes. Let's now talk about one of the most essential yet in often intimidating parts of low fidelity prototyping, sketching helps us visualize ideas quickly without the pressure of getting everything perfect. It's about thinking through drawing, not creating artwork. In low fidelity prototyping, sketching allows you to express ideas fast, explore alternatives, and communicate your version clearly to others before any code or digital design tools come into play. The key takeaway is that sketching isn't about being an artist, it's about thinking visually. The simpler your sketches, the faster you can iterate and share ideas with your team. Keep it rough and simple and focus on clarity but not perfection. Now, moving on to high fidelity prototype, also known as hi-fi prototyping. It represents a stage where the prototype closely resembles the final product in both appearance and function. It helps designers and stakeholders experience the product as it would actually appear and behave in real use. Unlike low fidelity prototypes, which focus mainly on idea exploration, high fidelity prototypes are built with realistic materials and interfaces. For example, a software prototype developed using Visual Basic offers a much clearer sense of the user interface flow than a paper sketch. Similarly, a molded plastic device with a dummy keyboard presents a more tangible version of the final form compared to an early wooden model. So, creating high fidelity prototypes requires suitable development tools. Um, some common software that have been used um, heavily includes Macromedia Director, Visual Basic, Smalltalk, etc. In this course, we will use Figma, which is a modernized software tool for designing high fidelity prototypes. So these tools are powerful, allowing the designer to build interactive versions quickly. Through though they are also development environments, the purpose here is not final product but simulate real interactions, test usability, and refine the design details. So, in summary, high fidelity prototypes are essential for validating design decisions and ensuring the final product meets both functional and experiential expectations. Now, this table highlights the key differences between low fidelity and high fidelity prototypes, comparing their advantages and disadvantages. It shows that each serves a distinct purpose in the design process, and the choice between them depends on the project stage and goal. Low fidelity prototypes are best suited for early idea exploration and concept validation, while high-fi prototyping are most valuable for testing usability, refining instructions, and demonstrating near final products. Successful design often involves moving from low to high fidelity prototypes through an interactive process to balance creativity, cost, and precision. Now, prototyping always involves making compromises between realism and efficiency. The goal is not to create a complete product, but to test particular aspects of a design quickly and effectively. Each prototype should therefore be purpose driven, focusing on answering specific designing questions. In the case of low fidelity prototypes, these compromises are usually clear, such as when using a paper based model that can not actually function. These prototypes help visualize structure or layout but cannot demonstrate actual system behavior. For high fidelity prototypes, the compromise can be more subtle. For example, the response speed might not reflect real system performance, and the icons and visual might be roughly drawn, or only a few key functions might be implemented. So, recognize these compromises and limitations are essential as it ensures both designer and stakeholders interpret test results appropriately and avoid overestimating the prototype completeness. So, in prototyping, one of the most important trade-off includes deciding between breadth and depth. Horizontal prototypes provide a broad overview of system functions, but only at a surface level. Vertical prototypes, on the other hand, explore a few functions in great depth, showing detailed interaction and behavior. Designers must choose between these approaches depending on what they aim to test or to demonstrate. Some compromises are not visible to users at all. For instance, a prototype might appear functional but could be built with weak internal logic or poorly structured code, often referred to as spaghetti code. This can create problems later in development if the prototype is mistaken for a solid foundation. Therefore, even when producing quick interactive prototypes, it's crucial to maintain sound design and good engineering principles. A prototype should guide learning and testing, not replace disciplined system environment. Now, once a design has gone through sufficient iterations of prototyping and evaluation, the next step is construction, turning the refined design into a fully functional product. At this stage, all lessons gathered from user testing and feedback are consolidated to create a stable system ready for deployment. While prototypes are valuable for exploring usability and interaction, they are not engineered for robustness. They are often limited in terms of error handling, performance optimization, and performance compatibility. Constructing the final system requires addressing these gaps through extensive quality testing, ensuring the product performs reliably under varied conditions and for a large user base. There are two primary development philosophies to transition from prototype to a product. The first is evolutionary prototyping, where the initial prototyping is continuously refined and eventually become the final product. This method demands strict testing throughout development to maintain code quality and stability. And the second is throwaway prototyping, where prototypes are used purely as experimental model to shape ideas. Once the design direction is validated, these prototypes are discarded and the final system is developed from the ground up. So both approaches are valid and often used. Evolutionary prototyping emphasizes is continuity and iteration, while Through prototyping emphasizes learning and rebuilding. The choice depends on the project scope and technical compatibility or complexity and risk tolerance and specific project idea. So that's all for this lecture. We will have one more recorded lecture for this module and some tutorials. So let's hope to see you in the next one.